Students, today we will discuss second chapter, inverse trigonometric functions. In this chapter, following topics are to be discussed: basic concept and properties of inverse trigonometric functions. See, students, we have studied invertible functions and we know trigonometric functions. So, let us define again invertible functions. We have already known that a function f from x to y is invertible if and only if f is bijective, that is 1 1 and 2. So let us start with sine inverse x. For that we have to draw the graph of sine x. Graph of sine x. So this is the graph of sine x. Here we can say that sine x is 1 1 and 2 in the interval minus pi by 2 pi by 2. This implies that sine inverse x exists in minus pi by 2 pi by 2. We have already studied a function f from x to y is invertible if and only if f is bijective 1 and 1 2. So if you take the interval this one, sin x will be invertible. We may take other intervals also, but this interval is known as principal value branch. And in this interval sin x is 1 1 and 2. That's why sin inverse x is taken in this interval. Sin inverse x is the angle for which sine is equal to x. For example, sine inverse 1 by 2. We have to think a angle for which sine is 1 by 2, that is 30 degree. So we may write pi by 6. Don't confuse with sine inverse x and sine x whole inverse. They are different because this gives us a real number and this is equal to Cossack x. Now let us know domain and range. So we know that sin x has the domain any real number and its range is minus 1 to 1. But sin inverse x has the domain minus 1 1 and the range. We have to think for which angle sin x is equal to minus 1, that is minus pi by 2. For which angle sin x is 1, that is pi by 2. You must remember the principal value branch of sine inverse x, that is from minus pi by 2 to pi by 2. To do such type of question, find the principal value of sine inverse minus 1 by 2. So the way is we have to think on an angle in this interval minus pi by 2 to pi by 2 for which sine is minus 1 by 2. So the way is, let sine inverse minus 1 by 2 is equal to y. Then sine y is equal to minus 1 by 2. Now this can be written as, we know that sine pi by 6 is 1 by 2, and here minus 1 by 2 occurs, so we may write sine minus pi by 6. This gives us minus 1 by 2. So from here we take which belongs to minus pi by 2, pi by 2. That's why y is equal to minus pi by 6. It means the principal value of sine inverse minus 1 by 2 is minus pi by 6. Now let us deal with graph of cos x. This is the graph of cos x, where it intersects x-axis at odd multiple of pi by 2, because there it becomes 0. Can we say cos x is bijective in interval 0 to pi? Yes, because we can see between these intervals, this is our pi, we can see 1 function. 1 is an element of y. An element of y has only one preimage. You may see that an element of y has only one preimage. So it is 1. It is onto, because in this interval between minus 1 and 1, every element is an image. So cos x is onto. This implies that cos inverse x exists in, of course, in other intervals also, like you may take 0 minus pi to 0, minus pi to 0, minus pi to 0, the graph is 1 on 2, but mathematicians accepted this interval as principal value branch. So cos inverse x is the value of angle for which cosine becomes x. Now let us discuss domain and range of cos x and cos inverse x. Here from the graph we can say the domain of cos x is if we take principal value, then here one thing is worth mentioning, that we should here we have to take for a 1 onto the cos x domain is But the domain of cos x is, you may write open interval minus infinity to infinity, and its range is minus 1 to 1. Whenever we discuss about its range, it becomes. Now we have to think according to it the range of cos inverse x. So we know that minus 1 is equal to cos pi. So we write pi here, and 1 is equal to cos 0. So we write 0 here. Find the principal value of cos inverse minus 1 by root 2. We have to find an angle for which cos is equal to minus 1 by root 2, but the angle belongs to this interval. So we can say, let then we know that in second quadrant cos becomes negative. So we should take, we know that this is minus cos pi by 4, and we may write it as cos pi minus pi by 4. As principal value branch is from 0 to pi. This implies that cos y is equal to cos, here we have 3 pi by 4. This implies that y is equal to, means cos inverse minus 1 by root 2 till now we can state that sine of sine inverse x is equal to x. Sine of sine inverse x is equal to x, where x belongs to, can you tell? Here see, this x is the domain of sine inverse x, and we know that the domain of sine inverse is minus 1 to 1. Here there is sine inverse sine x. This is also x. Here x belongs to, here we can see x is the range of sine inverse, and the range of sine inverse is minus pi by 2 to pi by 2. Likewise, in case of cos inverse we discuss. So if you take cos of cos inverse x, this is equal to x. Here x is the domain of cos inverse, that is minus 1 to 1. Cos inverse cos x, this is also x, where x belongs to, here x is the range of cos inverse, and its range is from 0 to pi. Let us deal with, this is our graph of 10x. Here we know that it is undefined on odd multiple of pi by 2. So on pi by 2, 3 pi by 2 minus pi by 2 minus 3 pi by 2. It is undefined. It wants to touch the graph, but it cannot touch. And it becomes 0 at integral multiple of pi. That's why it becomes 0 at pi, at 0, and at minus pi. Can we say that it is bijective? It is 1 1 and 2 in open interval minus pi by 2 to pi by 2. Yes, because an element of y an element, we know that x is the domain and y is the codomain. But in the interval, an element of y has only one pre-image. In this, minus pi by 2 to pi by 2. And every element of y is the image. That's why we can say tan x is bijective in interval minus pi by 2 to pi by 2. This implies that tan inverse x exists in this interval. However, tan x is not 1 onto in its domain, that is the set of real numbers. You may check here that you may have y in, for example, if you take 1 by root 2 in y, then you can see there are two or many values like pi by 4 and pi plus pi by 4, that is 5 pi by 4 in x. So 1 by root 2, an element of y has not only one pre-image, so tan x is not 1 in its set of real numbers. It is also not but it is onto, because you can see every y which is the set of real numbers has its pre-image, but tan x will not be bijective in the set of real numbers because it is not 1. So it is needed to restrict the domain of tan x so that it becomes bijective, and we take this interval. We may take other intervals also, but mathematicians accept this interval as principal value branch. So tan inverse exists in this, because we know that a function is invertible if it is if and only if it is bijective. So as tan x is bijective in this interval, so tan inverse exists in this interval. Let us discuss. For existence of inverse, we can say the domain of tan x. Here we write range. The domain of tan x is open interval minus pi by 2 to pi by 2, and its range is, we can see here, minus infinity to infinity. And we know that whenever we write inverse of a function, you may remember that we exchange range and domain. That clear? So the question is, find the principal value of tan inverse minus 1. Let tan inverse minus 1 is equal to y. Then tan y is equal to minus 1, which is minus tan pi by 4. This is equal to tan minus pi by 4. We have taken here minus pi by 4. Here minus pi by 4 belongs to the open interval minus pi by 2, which is principal value branch. Therefore, tan inverse minus 1 is equal to minus pi by 4. Now graph of cortex. We know that cortex is undefined at integral multiple of pi. So we can see at pi to pi minus pi or 0. It is undefined, it just want to touch. And at the odd multiple of pi by 2, its value becomes 0. That's why it intersects the x-axis at the odd multiple of pi by 2, that is minus pi by 2, pi by 2, 3 pi by 2. Here we can see that this graph is 1, 1 and 2 within the open interval 0 to pi. So cortex is bijective in open interval 0 to pi. This implies that cot inverse x exists in which is the principal value branch. Now, for existence of inverse, domain, range, here cortex, here cot inverse x. So domain will be open interval 0 to pi and range is it is clear from the graph. The range for this graph is here plus infinity, here minus infinity, here minus infinity. For this, the graph does not touch the line. So here we write minus infinity, infinity. Now we think for which angle of cot it becomes minus infinity. The answer is pi, and it becomes infinity for 0. So they are, you may see, they are interchanged. You know that whenever we discuss with inverse of a function, their domain and range are interchanged. So find the principal value of cot inverse of minus root 3. Let cot inverse minus root 3 is equal to y. Then cot y is equal to minus root 3, which is minus cot pi by 6. Cot 30 degree is root 3. Now we have to bring this angle within the interval 0 to pi. So this can be written as cot pi minus pi by 6, because we know that in second interval cot becomes negative. So why we take this value? Because principal value branch is open interval. Therefore cot inverse minus root 3, here y is equal to 5 pi by 6. Now graph of sec x. We know that sec x is undefined on an odd multiple of pi by 2. So we can see here pi by 2, minus pi by 2, and 3 pi by 2. Also minus 3 pi by 2. It is undefined, it is undefined, it is undefined. It just wants to touch this line. Now we have to take the interval for bijectivity. So if we take this value which lies between, you can see, which lies between 0 from 0 to pi except pi by 2, because at pi by 2 it is undefined. So we can write sec x is bijective in this implies that sec inverse x exists in for existence of sec inverse x. We have to restrict the domain of sec x, and the domain will be you may see the ranges now. This comes here. So the range of sec inverse can be thought from here that we can think for which value of x sec x becomes 1, so that is 0. For which value of x sec x becomes minus 1, that is pi. Now here infinity occurs, so we have to remove it. So at pi by 2, within this interval at pi by 2, sec x becomes at pi by 2 sec x sec pi by 2 becomes infinity. So we have to remove it. This interval is principal value branch. Now find the principal value of sec inverse minus 2 by root 3. So let sec inverse minus 2 by root 3 is equal to y. Then sec y is equal to minus 2 by root 3. Now we have to think y within the principal value branch. This is equal to minus sec pi by 3. This can be written as sec pi minus pi by 3, because the principal value branch is closed interval 0 to pi. This belongs to first and second quadrant. This can be brought in second quadrant, because in second quadrant sec becomes negative. That's why we write pi minus pi by 3. Therefore, sec inverse minus 2 by root 3 is equal to, here y is equal to 2 pi by 3. Now graph of Cossack x. Here Cossack x is undefined at integral multiple of pi. So we may see that at minus pi, 0, pi, 2 pi, it just wants to touch, and its value is more than 1 or 1, and minus 1 or less than minus 1. Now we have to restrict its domain so that it becomes bijective. So if we take this interval, these values, then we have the function. If we take interval from minus pi by 2 to pi by 2 except 0, then we have Cossack x 1 1 on 2. Cossack x is bijective in That's why cos inverse x exists in which is the principal value branch. This is decided as principal value branch by the mathematicians. And here it is written cos x is bijective in this interval. There are also so many intervals where cos x is bijective, but mathematicians accept it as principal value branch. And now a question. Before the question, let us discuss for the existence of Cossack inverse x, domain and range of Cos x and Cossack inverse x. So its domain becomes and range becomes, we know its value is this interval. Now this comes here and we can think for which value of x cos x becomes minus 1, for which value of x cos x becomes 1. There are also infinity here, so you have to remove it. For which value of x cos x becomes infinity. Now the question. Find the principal value of cosec inverse minus root 2. Let cosec inverse, then cosec y, this is minus cosec pi by, this can be written as cosec minus pi by 4 because minus pi by 4 belongs to the interval minus pi by 2 therefore cosec inverse minus root 2 is equal to minus pi by 4. Now you must know to draw the ITF, inverse trigonometric function, with their domain and range. So here sine inverse, we have to write its domain. So if you can remember the graph of sine x and its range, you can write its domain. So its domain is the range of sine x, which is minus 1 to 1. From here, likewise, the domain of cos inverse is the range of cos x. The domain of tan inverse is the range of tan x. The domain of cot inverse is the range of cot x. The domain of sec inverse is the range of sec x. The domain of cos inverse is the range of cosec. Now from this domain we can write the range. So we have to think the angle for which sin x becomes minus 1. It is minus pi by 2. Sin x becomes 1. It is pi by 2. We have to think x for which cos x becomes minus 1. Pi 1 0. We have to think x for which tan x becomes minus infinity. Here it is open interval, so we have to take open interval. Now for this we know for cot 0 it becomes infinity, for cot pi it becomes minus infinity. Here we have to think x for which sec x becomes one minus 1. Here also infinity, we have to remove pi by 2 from this interval. Here you have to think x for which cos x becomes minus 1, 1. Within this interval, there exists 0, so we have to remove 0 because at 0, cos x becomes infinity. You must remember these ranges, and if you remember this domain, and for writing this domain, if you remember the graph of the trigonometric functions, then you can remember these ranges, and it will be quite helpful for finding the principal values. That's all for doing exercise 2.1 of NCERT.